Hello everyone, I'm Abasoon and welcome to my course on secure communication. So in this lecture we'll be discussing about wireless communication. Let's start with that. There are many different implementation of wireless networks as well. We of course have used wireless local area network based on 802.11 standard and the 2.4 and 5 gigahertz range. But we have also seen a lot of other wireless communication developed over the last year. For example, Zigbee. Zigbee is an open standard for Internet of Thing communication. The being how idea of Bluetooth or 802.15.4 standard. We can support smart building through integrating all of these various smart devices together. For example, thermostats and light and we can control then the energy consumption, the heating and the cooling of the building, as well as link it to the access control of various floor of the building as well. We have uh, LYFI. This is a wireless technology based on light emitting diodes. So instead of using something like 802.111, which is a radio frequency signal, we will use rather an optical link. But transducer in this case are based on LEDs rather than other type of laser type signal. The problem with LIFI is that it's very good to transmit across a network, for example, a warehouse floor or a large open area, but it does not penetrate to doors and walls. This is both the advantage and disadvantage in that it contains the signal within that building and cannot be picked up from the outside like most of the 802.11 signals, but also limit it just to the area directly within the range of a various trans receivers. This can work really well when we deal with translation type of devices or other type of communication where a person can wander around throughout the floor area and able to pick up the signal based on a little transceiver that they could wear across their neck. One of the advantage of LIFI is not susceptible to electromagnetic interferences like mm, like the jamming would happen in the case of regular wireless local area network signal. There hasn't been a lot of N LYFI growth. It has a limited amount of growth, but it is used, as we say, often in conference center and so on. We also have a mobile phones, and this is a primary use for telephony these days. And and this requires that we have a clear policies. If a person is going to use a mobile phone and they are going to discuss very sensitive information, we have to answer whether or not that's a good idea. A mobile phone signal can easily be picked up and listened to. For example, the various type of fake calls, tower stringency type of devices. So we need to have a policy in place. Our policy can require that we use secure telephones, or they could control things like BYOD, that is bring your own device, or even choose your own device, so that the people are choosing phones that they have better security capabilities in them. We should also use the MDM, that is mobile device management things, that will allow us to create a container or virtual area on the phones where we can keep sensitive records, files, data as well. Of course, allow us to LoJack or be able to disable that mobile if it was to be stolen, was to be lost or stolen. We have had a number of different technologies we have used over the years in mobile phone area, from of course our early analog phones, the first generation, to the second generation and the third generation phone. But now then, along with the 4G, the 4G is many ways was not actually 4G. It is merely a 3G plus. It's a bit of marketing, but the idea behind 4G was that we could introduce now LTE communication, that is long term evolution. It is allow us to have a broadband always on a cell phone network that give us access to internet services and other IP based packet switching communication. Part of the problem with this, of course, is that with a mobile phone, it only encrypts the data from the phone itself to the cell tower. It does not actually encrypt it, goes over to the internet. Within that would have to be done at higher say application level. Today we have a lot of evolution towards 5G. 5G is completely different technology than 3G and 4G we had before. In 5G we are going to able to support much more of these always on keep to use part of your critical infrastructure, so that now we can support things like automated vehicles, automation of various types of operation, and can connect to the things like robots or manufacturing that requires real-time communication. So it supports Internet of Things, machines, SCADA devices. We will use this a lot of transportation monitoring of courses, various type of anomalous vehicles as well as transportation network. 5G security also is a great improvement over what we saw before. 5G security is encrypted using IMSI, which provides first confidentiality of a communication, higher assurance of integrity, as well mutual authentication between the actual devices. We know that satellite is very useful, especially in areas that are rather remote, and satellite allow us to communicate now from pretty much anywhere in the world. We can beam a signal off to the satellite, and now there are disadvantage, of course, in latency. Sorry. So in latency, or the delay that is taken for the signal to go with the satellite and back. And when a signal come off of the satellite, it has a large footprint. In other words, the signal can be picked up from a very large area, not just the intended person. For that reason, we are required to encrypt our transmission, protect the various base stations or ground stations as well. With physical security, we should do hardware authentication to prevent the interruption or taking over of session. One of the things we have seen is that a lot of our satellite communications are still immature in the area of encryption and authentication. So we have seen cases where the people or the country have been able to affect things like GPS signal, throw them those coordinates. Or we saw this with some shipping where affecting the GPS signal would allow them to divert ships that thought they were in one place that actually were in a different location. There's always the risk of equipment failure. There is of course the risk too, even of people intentionally disabling the satellite communication, or problem of course of them some type of conflict related to them. But from a natural sense, satellite can be very much be effective by solar activities, solar flares that can disable satellite communication. The key point review, we need to establish the secure communication. This means we have to pay attention to the areas of architecture, the configuration as well as monitoring of network and our communication infrastructure.